Hello and good afternoon. CSI158, Section 841 and 847 students for the second 8-week term at Anne Arundel Community College. Today's PacketTracer tutorial video is going to cover the solution set for PacketTracer 3.2.1.7, which is going to cover Vlans, because Chapter 3 was a very large chapter and it had a lot of information on Vlans, virtual local area networks. Alright, so we have our addressing table here at the top for our PC devices. The objectives are going to be to verify the default VLAN configuration, configure VLANs, and assign VLANs to ports. So again, VLANs are helpful in the administration of logical groups, allowing members of a group to be easily moved, changed, or added. This activity focuses on creating and naming VLANs and assigning access ports to VLANs. So let's go ahead and jump in here. So step 1, display the current VLANs. So here is switch 1. So we're going to go ahead and click on switch 1 and we're going to pull up the command line interface. We'll go from user exec mode, because right now if I do show VLAN, we'll get some information here. And you'll see that it looks like just about everything is in the default VLAN. So I'm going to move into privilege exec mode, and let's make sure we see the same thing, and we do. So you can do the show VLAN command from either privilege exec mode or user exec mode. Okay, so by default all interfaces are assigned to VLAN 1, and as you can see here, all 24 interfaces, including the 2 gigabit Ethernet interfaces, are in VLAN 1. So step 2, verify connectivity between PCs on the same network. Right? So Pc1 can ping Pc4, Pc2 can ping Pc5, and Pc3 can ping Pc6. Pings to the other PCs should fail. Alright, so what benefit will configuring VLANs provide to the current configuration? It's going to allow us to segregate the hosts that should be on the same VLAN from the other hosts, and that way hosts on VLAN 10 are not going to see the traffic from hosts on VLAN 20 or VLAN 30. Hosts on VLAN 20 will not see any of the traffic from hosts on VLAN 10 or VLAN 30. And finally, VLAN 30 hosts, so PC3 and PC6, will not see traffic from VLANs 10 or 20. So again, it allows us to segregate the traffic off. So part 2, configure the VLANs. So we're going to create and name VLANs on switch 1. So let's bring switch 1 back up again. As you can see here, we only have the default VLAN today. And again, you cannot remove VLAN 1. VLAN 1 will always be present on the switch. And this is again with Cisco switches. It's different with other vendors. Okay, so create and name VLANs on switch 1. So we're going to create the following VLANs. It says names are case sensitive. So I'm going to go ahead and type in config T to move to global config mode, where I'll type in VLAN 10. And this is how you create the VLAN. You'll notice it moves us into VLAN configuration mode, where I can now provide it with a name. So we'll say faculty/staff for the name of that VLAN. And now here's what you can do. So we're already in VLAN configuration mode, so I can go ahead and continue. So let's say VLAN 20, and now I'm going to type in name, and this is students, and then VLAN 30, and then I'm going to type in name, and it's guest, open parens, default, default, and then I'm going to type in VLAN 99, and the name is management and native. Okay, so we've created our VLAN, so let's go ahead and type the end command to remove us from VLAN config mode. It's going to take us back to privilege exec. Let's save our configuration to make sure that we don't lose any of this configuration information if the switch were to power cycle or to be reloaded. So now if I do a show VLAN, you can see that we've created a number of different VLANs here. So these now show in the output of on our switch. And so now these VLANs have been created on our switch. So VLAN 10, 20, 30, and 99. Okay, one of the other commands that the text showed was the show VLAN brief command. right? And again, if you look, it shows you much of the same information, but a little less. It doesn't show us all of the information that we normally saw up here at the top, right? Specifically, this piece of the table. And you'll remember that the VLAN names can be 32 characters long, and that's the max. All right, so we've created our VLANs on switch 1. We've verified our configuration status. So now it says create the VLANs on switch 2 and switch 3. And so now we're going to want to do these same tasks on switch 2 and switch 3. And it says use the same commands from step 1 to do the same thing on switch 2 and switch 3. So let's go ahead and do that. We'll pull switch 2 up. And this is excellent practice. So we'll go from user exec to privilege exec, from privilege exec into global config mode, where we're going to go ahead and create our first VLAN, VLAN 10. And again, we're using the same commands, faculty, staff. And again, right from VLAN config mode, I can enter in the next one. I don't have to exit up one level. So VLAN 20 is for students. Oh, whoops, I apologize. VLAN 20, name, students. And then we have VLAN 30, and that is our guest. And then we have VLAN 99. Oops, sorry, I'm going to have to change that name. So it's guest, and we've got default. And then we've got VLAN 99, which is going to have the name of management and native. All right. So let's go ahead and type end. And we'll do a write mem to save our running configuration to the startup config. And we'll do the show VLAN command. Let's make sure we've got our names in there. We sure do, right? VLAN 10, 20, 30, and 99. If I do a show VLAN brief, again, you can see VLANs 10, 20, 30, and 99, but no ports in these VLANs yet. And that's important. You'll notice that all of the ports are still in the default VLAN. So we're going to get to that in a second. All right, so let's pull up switch number 3. And again, user exec, we're going to type enable to go to privilege exec. From privilege exec, we're going to type configure terminal or config T to get into global config mode. And this is where we're going to go ahead and create our VLANs one more time. Now, while I'm creating these, you're probably wondering, if I had 50 switches, would I have to do the same steps if I had PCs in these VLANs or wanted to have these VLANs configured? And the answer is yes and no. So you would have to do it if you didn't want to use what Cisco refers to as VTP. And what you can do there is you can create, it's a VLAN trunking protocol, and it allows you to create different domains. And we're not there yet. I believe we talk about it in the Routing and Switching Essentials course. But this is something where if you were creating larger switch layer 2 domains and you had these VLANs and they needed to span across multiple switches for whatever reason, you may want to look at the VLAN trunking protocol. So there we go, VLAN 20, the name students, and then VLAN 30 with the name of guest default. And then VLAN 99, and the name is management and native. Management and native. All right, so again, we'll type in to take us back to privilege exec, where we will save our configuration. I will now do a show VLAN, and there they are, 10, 20, 30, and 99, and then a show VLAN brief. And again, you can see VLANs 10, 20, 30, and 99, all with the correct names. All right. So now that we've done that, we've created those same VLANs on switch 2 and switch 3. Now we're going to assign VLANs to ports. And this is very important because this is how you would assign a port to a specific VLAN, and then that PC is going to have connectivity within that VLAN and that VLAN only. So it says assign VLANs to the active ports on switch 2. And so here's switch 2. You can see FA06, 18, and 11. Right? So FA06, FA018, and FA11. And we're going to go ahead and do that on switch number 2. So we'll pull switch 2 up. And so it shows us there VLAN 10 is going to be on fast Ethernet. So we'll go from privilege exec to global config, and we now need to get into the interface. And first, if I do show run, you can see, let's take a look at fast Ethernet 11, right? So there's no configuration there at all at this point on 6, 11, or 18. All right, so what we're going to do is we're going to go into interface, fast Ethernet 011. We're going to turn this so we have a host plugged in there, right? So we're going to go switch port mode access, make it an access port, and then switch port access VLAN. And again, we're on FA011, so this would be part of VLAN 10. Okay? And so FA011 is going to be on VLAN 10, so I'll add a quick description in here, and we'll just say Pc1 on VLAN 10. All right, so that's FA011. So now we need to configure interface FA0/18. So we're going to run the same steps again, and this is really good practice. Switch port mode access. So we're turning this port into an access port as opposed to a trunk port. So switch port mode access, switch port access VLAN 20 for port or for fast Ethernet port 0/18, and then again we'll put a quick description on here. And let me see which PC that is. So it's going to be PC2. PC2 on VLAN 20. All right, and now we're going to go into interface fast Ethernet 0/6. We're going to do the same thing. Switch port mode access to make sure that it's an access port where you would plug the host into, as opposed to a trunk port where we would plug in another switch. All right, we'll do switch port access VLAN 30 because that's the VLAN that port or fast Ethernet port 0/6 is going to be in. And again, finally, we'll put a quick description on here, and let me confirm that's PC3, and it is. So we'll say PC3 on VLAN 30. All right. So again, very important, we want to type N to get out of interface config mode, and it moves us back into privilege exec. From here, most important step, save that configuration. All right, so now I'm going to go ahead and do a show run so we can take a look at our interfaces. So there's FA06, fast Ethernet 06. As you can see, the description is there. It shows our switch port access VLAN 30 and switch port mode access. Let's go down and take a look at FA011. Again, our description, switch port access VLAN 10 and switch port mode access. And then there's fast Ethernet port 0/18, right, on VLAN 20. And that's the only configuration information we've put on here. So if I do a show VLAN, now you can see when we do the show VLAN command that the faculty, staff, the students, and the guest default, those now show that they have a port that has been placed into these VLANs, or a VLAN has been assigned to these ports. And so this is a very quick way for you to see which ports belong to which VLANs. If you look above here in the default VLAN, which is VLAN 1, you'll notice that FA011, 018, and 06 no longer show. So 6 would have been here, 11 would have been right there, and 18 would have been right here. But they've now been assigned to these different VLANs that we've created over here. All right, so if I do a show VLAN brief, you'll see that we see much of the same information, just in a truncated format. So now, to prove that we've saved our configuration and that it'll be persistent across reboots, because again, remember, we've written the running configuration, which is the configuration that we're manipulating. We've written that or copied it over to the startup configuration. And the startup configuration is in non-volatile storage space, whereas the running configuration is in volatile storage space. So here we go with the switch to user exec. We'll go into privilege exec, and if I do a show VLAN brief, show VLAN brief, as you can see, all of our VLANs are still there. If I do a show run, VLAN 6 is configured, VLAN 11 is configured, and there's VLAN 18. So again, very important that you do write memory or simply just WRIMEM to save your configuration off. Okay, so that's switch number 2. So here it says step number 2. So assign VLANs to the active ports on switch 3. So switch 3 uses the same VLAN access port assignment as switch 2. So again, we're going to recreate this information, this time on switch 3. You'll notice switch 1, there are no hosts attached to switch 1. Okay, so on switch 3 we're going to go into global config mode and then interface config mode. We'll start with Fa011 and we're going to do switch port mode access and then switch port access VLAN 10. And again, a quick description, and we'll just put Pc4 on VLAN 10. And then we'll switch our interfaces. We'll move to interface fast Ethernet 0/18. So we'll set it up as an access port, switch port mode access, switch port access VLAN 20. And then again, a quick description. And if I'm not mistaken, it's going to be PC5 and then PC6. Yep. So PC5 on VLAN 20. And then we'll go into Interface Fast Ethernet 06, where we'll type in here switch port mode access. Again, making sure it's an access port for hosts. And then switch port access VLAN 30. And then a quick description, PC6 on VLAN 30. All right. So as you can see, if you glance over here, our completion is 90 out of 90, so we're fully configured. So let's go ahead and type end. So we know we've got our configuration correct, and I think we're going to verify some connectivity between these different hosts. So switch 3's config is all set up. So it says verify loss of connectivity. So previously, PCs that shared the same network could ping each other successfully because, again, they were all on VLAN 1. So try pinging between PC1 and Pc4. So if I'm here on PC1, which is VLAN 10, I'm going to try to ping across here to Pc4. So let's do that now. So if I ping 172.17.10.24, and you can see those guys are both on VLAN 10. And so now I'm sure we've got some ARP messages going back and forth. And let's see if we've got connectivity back across. So our requests are continuing to time out. So if you see that they're both on VLAN 10, but yet we don't have any connectivity, right? It says, try pinging between PC1 and PC4. Although the access ports are assigned to the appropriate VLANs, were the pings successful? And then it wants to know why or why not, and what could be done to resolve this issue. So clearly, we're unable to ping between PC1 and PC4. So if we take a look at the IP configuration to confirm that the IP is correct, and it is a /24, we don't need a default gateway because, again, these guys are on the same VLAN or the same subnet network. So you'll come over here, and you'll take a look to confirm 172.17.10.24, and again it does have a class C address here. And so given that these are both in the same VLAN, you should be able to ping from one host to the other host. So switch 3, switch 1, and switch 2. Now before, when everybody was in VLAN 1, these inter-switch connections that run between switch 2 and switch 1 and switch 1 and switch 3, the traffic on VLAN 1 would automatically go across these links. But now that we've created additional VLANs, those VLANs are not set up to go over these links. In fact, these links would need to be trunk links. So what could be done to resolve this issue? Well, let's go ahead and we'll pull up switch 3. And we're going to go ahead and change gig 1-2 into a trunk link. So interface gig 1-2, because remember, a trunk link will allow you to pass multiple VLANs across it. So it's not currently a trunk. So if I do a do show interface trunk, right, you can see we have no trunk link. So let's go ahead and create one. So instead of switch port mode access, we're going to do switch port mode trunk. right? And so we're going to turn that into a trunk link. So now if I do a do show interfaces trunk, aha, port gig 1-2, VLANs allowed and active in management domain are going to be 1, 10, 20, 30, and 99. So what this is telling me is that all of my VLANs are allowed to come across this 802.1q, which is an open standard, trunking port. And so the mode is on because I've forced it to be a trunk. So let's go ahead and take a look. We'll close this down. So now our trunk link is set up here on switch 3. Let's take a look at switch 1 on gig 1-2. And I'll go into privilege exec and we'll do a show interfaces trunk. Alright, so it looks like the trunk port mode was auto. So when we forced the trunking mode on switch 3 by doing the switch port mode trunk, the auto mode here on switch 1 detected that change and negotiated successfully a trunk between switch 3 and switch 1. Now, according to our reading, this is something that you would want to hard code. So let's go ahead and do that right now. So if I'm on switch 1, I'm going to go into interface gigabit Ethernet 1-2, and I'll do a switch port mode trunk, right? So we'll hard code that so that it doesn't go from, it should change, the mode should change from auto status into the on status. So we'll do show interface trunk, and as you can see, our mode has changed because we are forcing that port to be on as a trunk instead of here where it said it was auto, and the N in front of the 802.1q for the encapsulation says that it had to negotiate the 802.1q. Whereas here it is forcing the encapsulation to be 802.1q. And so again, you could also do switch port trunk, and we could put allowed VLANs on here. We could also indicate what the native VLAN is. So if we take a look back over here, we created quite a few VLANs, right? And VLAN 99 is the management or native VLAN. So I'm going to set that here. So native VLAN, and then you put your VLAN in. So we'll say it's 99. And again, we've already completed the exercise, but with the percentage down here in the bottom right. But these are some very important commands that you want to take a look at, and also to help you troubleshoot. So we've set the trunk native VLAN to 99. Now, we haven't done that over on switch number 3, so we're going to have to go back and do that. And as I was hoping, this is the error message that you're going to see. So the Cisco Discovery Protocol has determined that there is a native VLAN mismatch. And that's true because we are, on this switch here, we are native VLAN 99 that we just set up. And you'll notice that over on switch 3 on gig 1-2, it says it's VLAN 1, and that is the default native VLAN. Okay, so we've finished our work here on switch 1. Let's go ahead and do the same thing for port gig 1-1. So we'll go into gig 1-1. We'll do switch port mode trunk, right? And then we'll also do switch port trunk native VLAN 99. So now we're going to start receiving 2 sets of error messages because switch number 1, which is here, these 2 ports, we've just changed their native VLAN on the trunk link to be VLAN 99. On switch 2 and switch 3, that native VLAN is currently set to 1, which is the default native VLAN for a trunk link. All right, so I'm going to let this run here for a couple seconds, and I want to make sure that we see native VLAN mismatch errors for both switch 3 as well as switch 2. And so let's go ahead and make sure that we see that. So now if I do a do show interfaces trunk to show me the trunking interfaces, you can see that the 2 ports that we've manipulated, gig 1-1 and 1-2, their mode is both on. They've got 802.1q encapsulation. The status is that they're trunking, and here are the native VLANs. This shows us the VLANs that are allowed. And again, here we go. We're now seeing for switch 2 just like we were, and there's switch 3's message. For switch 2 and switch 3, we're now seeing native VLAN mismatches. So let me go ahead and in the session on switch 1, I'm going to copy my running config to my startup config to make sure we keep that. And let's come back over here to switch number 3. As you can see, switch 3 is also reporting native VLAN mismatch errors. So let's go into interface gigabit 1/2. So switch port trunk native VLAN 99 will resolve that issue. All right, so now I've assigned the native VLAN. Okay. And so if I do a do show interfaces trunk, you can see that the mode is on. It's trunking. The native VLAN is now changed, whereas before, if I scroll up, you can see here, prior to that, the native VLAN showed as VLAN 1. We've just changed that, and now the native VLAN is VLAN 99, and these are the VLANs that are allowed in the active management domain. VLANs allowed on the trunk are 1 through 1005. Okay, so we've fixed that error message problem, so let's go ahead and save our config with a write mem. Now let's finally come over here to switch number 2. And as you would expect, we're seeing messages between switch 2 and switch 1 that there is a native VLAN mismatch, so let's go ahead and take care of that. So we'll go into interface gigabit Ethernet 1.1. We're going to do switch port mode trunk to make it so that it's in the on status. If I do a show interfaces trunk, you can see that the mode is on, but the native VLAN is still 1, so we'll do a switch port trunk native VLAN 99 so that those match. And so now, if I do a show interfaces trunk, you can see that the VLAN, the native VLAN has changed and the mode is on. So we'll type N. We'll do a write mem to save our configuration. And now, if I come over to Pc1 and attempt to ping over to Pc4, we would expect to have success, and sure enough, we do. So Pc1 can ping Pc4. Now let's make sure that works both ways. Can Pc4 ping Pc1? So 172.17.10.21. So Pc4 can ping Pc1. How about Pc5? Let's make sure that each of these can get across those trunk links that we just configured. So I'm going to try to ping 172.17.20.22. And Pc5 can ping Pc2. Can Pc2 come back over to Pc5? So we'll ping 172.17.20.25. And sure enough, we have success. And so finally, let's check Pc6 and Pc3. So if you see here, I'm going to ping 172.17.30.23. And that works. And lastly, we're going to go from Pc3 over to Pc6. So I'm going to go ahead and ping 172.17.30.26. And that works. And so let's also do one quick check. So from Pc3, can I ping Pc2? 172.17.20.22. Because these guys are on different VLANs. As where originally they were all on the same VLAN, now they're on different VLANs, and as you can see, their traffic cannot be seen between the two of them. So again, we've created virtual local area networks, and those are segregated from other VLANs, so the traffic between these VLANs will not be visible to the hosts that are in different VLANs. But if you're in the same VLAN, such as Pc1 and 4, or 2 and 5, or 3 and 6, they will be able to see their information. They will be able to see the packets and the network traffic because they are in the same VLAN. All right, so this has been PacketTracer Activity 3.2.1.7. As you can see, we ended up with 100%, 90 out of 90. And we also were able to resolve the issues here with the trunk links, ensuring that we had the native VLANs or the native VLAN and the management VLAN properly configured on the trunk links between these switches. Because again, remember, as soon as you start creating VLANs, VLAN 1, which is the default VLAN for trunk links as the native VLAN, you're going to start to need to create trunk links, and you're going to need to make sure that the VLANs that you have created are able to traverse those trunk links. All right. Again, this has been for CSI158 Section 841 and 847 students at Anne Arundel Community College for the second 8-week term in the spring 2014 semester. Enjoy the rest of your weekend, and I'll see you next week.